So 20A, points A and B have coordinates 2, -3 and 7, 9 respectively. Find the length AB. So the length AB is given by this formula. So where we have x1 minus x2 squared plus y1 minus y2 squared. So that is the formula for the length of a straight line. So we have 2, -3 as our A, and we have 7, 9 as our B. So this is x1, y1, x2, y2. So AB is equal to, so x1 it is 2, x2 it is 7, y1 is -3, y2 is 9. So AB is equal to 2 minus 7, that is -5, squared plus -3 minus 9, that is -12 squared. So AB is equal to -5 squared, that is +25. -12 squared is 144. So AB is equal to square root of 25 plus 144, it is 169. So the square root of 169, it is 13. So AB is equal to 13, you say, units. That is the answer. Part B, given that y is equal to 4x to the power 3 minus 3x to the power 2 plus 5x. So find dy dx. So this is calculus differentiation. So dy dx is equal to, remember that we are differentiating with respect to x. So what we do is you multiply this power from x times the coefficient of x, which is 4. So 3 times 4, it is going to give us 12x. Then you subtract the power of x. Then you say the power of x, which is 3 minus 1, which is 2. Minus, you do the same here. You multiply this power 2 times 3 to give you 6. Then you subtract 2 minus 1, which is 1. We don't write 1. Okay, so x to the power 1, it is just x. Then now you do the same here, plus. So this is power 1. So this simply means it is power 1. So 1 times 5, it is 5. So x 1 minus 1, it is 0. So any number or letter to the power 0, it is 1. So there is no need for you to write x to the power 0 there. So this is the answer. Question 21. Write down the 3 inequalities that define the unshaded region R on the diagram below. We have this line which passes through 0, 0, 1, 1, and we have 7, 7. So this line, it is a special case line. So this is a special case line. It passes through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. So it is a special case line which is called y is equal to x. So that is equation 1. Then equation 2, we have this line. Okay, so we have 7,3, we have 7,7. So this is a special line. It is cutting x at 7. Okay, 7 is constant. So this is x is equal to 7. So this line, it is called x is equal to 7. So remember that this is x is equal to 0, x is equal to 1, x is equal to 2, x is equal to 3, x is equal to 4, x is equal to 5, x is equal to 6, x is equal to 7. So these lines, they are x lines. Then we've got the third line, which is this line. So this one, it is not a special case line. If it is not a special case line, you use this formula. Y is equal to mx plus c. So that is the equation that we need to use, where m, it is gradient, c, it is the y-intercept. So c, it is the y-intercept. So in this line, we don't know the y-intercept there. So we're going to start by finding m, which is gradient. So how do we find gradient? So this is the equation. So gradient is y1 minus y2 over x1 minus x2. So this is the equation that we use to find gradient of a straight line. So we've been given two pairs of coordinates in this line. So there is this 1, 1 and there is 7, 3. So 1, 1 and we have 7, 3. So remember that a coordinate, it is x, y, x, y. So if this is x1, y1, this is x2, y2. So this can be x1, y1, x2, y2. There is no problem. The answer is just the same. So now let us ingest these values in the formula. So gradient is equal to y1 is 1, y2 is 3, x1 is 1, x2 is 7. So gradient is equal to 1 minus 3, it is negative 2. 1 minus 7, it is negative 6. So remember that negative and negative goes 2 into 2, 1. 2 into 6, 3. So gradient is 1 over 3. From here now, where there is m in this equation, I'll substitute 1 over 3. So y is equal to 1 over 3x plus c. So I'll find now the value of c. So finding the value of c, I need to pick n of the two coordinates. So I'm going to pick 1, 1. So where y is equal to 1. So where there is y, I'll put 1. Where there is x, I'll put 1 plus c. So 1 is equal to 1 over 3 times 1. It is 1 over 3 plus c. So I'll just correct the like terms. So 1 over 3 to go this side. It will be 1 over 3 is equal to c. So this is a fraction. I can express this one to be a fraction as well by saying over 1. So 1, so 3 times 1, that is 3. 1 times 1, that is 1. Over 1 times 3, that is 3, is equal to c. So c is equal to 3 minus 1, that is 2 over 3. So 2 over 3, it's a value for c. So the equation now, y is equal to 1 over 3 x plus 2 over 3. So this is the third equation. So from here, Let us now write the inequalities. So you need to understand that for every straight line which passes like this, so this side it is greater, this side it is less. So this is the line that we have, which is y is equal to x. So we want to define where region R. So for this line, region R is this side. So in this case, it is here. So for this line, region R is less. So this line, region R, it is less. So we are going to put less than or equal to x. Now we come to this line. So all the lines that passes like this. So remember that this is 7. So 6 is somewhere here. This is 7. 8 is here. So meaning for this line, this is less party and this is greater part. So for all the lines, this is greater and this is less. So for this line, R is this side. So it is on the less party. So it is going to be x is less than 7. So it is going to be less than. Why? It is a dotted line. It's a dotted line. So we are not going to put the equal to. And we have now this line. So this line, it is the same as this one. Okay? So for this line, R is on the upper side. So for this line, the upper side is greater. So we are going to say y is greater or equal to 1 over 3 x plus 2 over 3. So these are the three inequalities that we have for the diagram that is given. 22a. The components of the vectors OA and OB are 2,3 and 4,2 respectively. The meaning of the word respectively, it means OA, it is 2,3. OB, it is 4,2. Write down vector BA as a column vector. So we call this as position vector. So position vectors, these are vectors that starts from the origin. So from the origin, which is at the center. Okay, so let's make the formula. So vector BA is equal to vector BO plus OA. So that is our formula. So vector BA is equal to, so we want vector BA. So in my formula, I'll go on B. So in my formula, it will be BO plus OA. So they must be the same here. Okay, so BO, so what we have is OB. So what we have is OB. But in my formula, it is BO. So this is going to be negative. Okay, because there is a change of direction. What I have is OB. But in my formula, it is BO. So this is going to be negative. So negative 4,2 plus OA. So OA, it is 2,3. So vector BA is equal to negative 4 plus 2. The answer is negative 2. Negative 2 plus 3. The answer is positive 1. So this is vector BA. But B, the diagram shows the sketch of the graph y is equal to 3 minus 2x minus x squared passing through A, B, and C. A, B, and C. So the question is, find, number 1, the coordinates of the points A and C. So A and C. So the points A and C are in the x-axis. So in the x-axis, we need to understand that y is equal to 0. That is in the x-axis. So in the x-axis, y is equal to 0. So in this formula where there is y, I'll put 0 so that I find the values of x, which is A and C. So where there is y, I'll substitute 0. So it is going to be 3 minus 2x minus x squared is equal to 0. So the second thing that I'll do, I'm going to rearrange. Remember the order of the quadratic equation. So this is the quadratic equation. Remember the order. The order must be y is equal to ax squared plus bx plus c. So that must be the order. So the one which has the power 2, it will be on the first part. So it will be negative x squared minus 2x plus 3 is equal to 0. So what I would do is I'll divide throughout with negative so that I remain with x squared. So over negative, over negative, over negative, over negative. So negative, negative, it is positive, so it will be positive x. Negative into negative, it is positive, so positive 2x. Negative into positive, it is negative, is equal to 0. And then from there now, I'm going to factorize. So this is sum and this is the product. So I'm going to find the factors of 3, which is the product. So factors of 3, these are numbers that can go into 3 without leaving a remainder. So factors of 3, we have 1 and 3. So these are the factors of 3. So 1 times 3, it is 3. So from these two numbers, we will get the same two numbers and we are going to add them so that we have positive 2x, so which is a sum. So for me to have positive 2x, it is going to be 3 minus 1, which is 2. So it will be 3x minus x. It is going to be 2x. So 3 times this is negative 1 is equal to negative 3. So which is this negative 3. So I'll just change on sum. So it will be x squared. I'll substitute where there is positive 2x, I'll substitute 3x minus x. So plus 3x minus x minus 3 is equal to 0. And this is now factorization by grouping. So I'll group like this. So what is common here? It is x. X into x squared, it is x. X into 3x, that is 3, minus. What is common here? It is 1. So 1 into x, it is x. Negative into negative, that is positive. So 1 into 3, it is 3, is equal to 0. So I'll say x minus 1, x plus 3 is equal to 0. So this is the 0 product. So I'm going to make two equations. Equation 1, it is x minus 1 is equal to 0, or x plus 3 is equal to 0. So this is negative 1. When it goes this side, it will be positive 1. This is positive 3. When it goes this side, it will be negative 3. So that simply means that x is 1, x is negative 3. So we are going to check where there is a and b, which one can be negative and which one can be positive. So C, it is positive 1. A, it is negative 3. So this is negative 3. And this is positive 1. So we are looking for the coordinates now. So the coordinates of A and B are, so here, this is negative 3, 0. This is 1, 0. In this line, x-axis, y is what? 0. And remember that a coordinate, it is x, y. So y is 0. So x is negative 3, y is 0. So for A, it will be negative 3, 0. Then for C, it will be 1, 0. So these are the two coordinates that we have. Part 2. Find the turning point of the graph. So this is the turning point. So coordinate of the turning point. So I need the value of x. And I also need the value of y. So how do we find the value of x and how do we find the value of y for us to find the coordinate of the turning point? To find the value of x, we use this formula, negative b over 2a. To find the value of y, we use this formula, y is equal to 4ac minus b squared over 4a. So our original equation is this one. So this is our original equation. So it is y equals 3 minus 2x minus x squared. So remember the quadratic formula. So this is squared. So I can say ax squared, I'll pair them. Okay? X squared. So this is ax squared. This is bx. This is c. So meaning the value for a, the coefficient of x squared here, it is negative 1. So it is negative 1. The value for b, it is negative 2. The value for c is positive 3. So from there, I'll just substitute. Where there is b, I'll substitute negative 2. Where there is a, I'll substitute negative 1. Where there is c, I'll substitute positive 3. That's how we can find the value of x and the value of y. So x equals, where there is b, I'll substitute negative 2. So this negative, it is from the formula, and b itself is a negative. Over 2a is negative 1. So x is equal to negative, that is positive 2. 2 times negative 1, it is negative 2. Negative 2 into 2, the answer is negative 1. That is the value for x. So now let's find the value of y. So y is equal to, where there is a, I'll substitute negative 1. Where there is c, 3, minus where there is b, negative 2 squared, over where there is a, negative 1. So y is equal to 4 times negative 1 times 3 it is negative 12 minus negative 2 squared, that is positive 4, over negative 4, which is 4 times negative 1. So y is equal to negative 12 minus 4. It is negative 16 over negative 4. So y is equal to negative 4 into negative 16. It is positive 4. So now the coordinate of the turning point becomes x comma y, so of which x is negative 1, of which y it is 4. So negative 1 comma 4 is the coordinate of the turning point. Question 23. The following diagram is the speed time graph of a car. Part A, calculate the acceleration of the car during the first 5 seconds. So acceleration is equal to final velocity minus initial velocity over time taken. So acceleration is equal to, so this is our final velocity. The initial velocity is 0 and the final velocity is 20. So the time taken is 5 seconds. 20 minus 0 over 5. So acceleration is 20 over 5. Acceleration is equal to 5 into 20. It is 4 meters per second squared. So that is our acceleration. Part B, find the value of t given that the total distance traveled was 550 meters. So this is t. So how do we find the value of t? So we have been given the total distance. So how do we calculate the distance of the travel graph? So we can calculate distance by calculating the area of the plane figure given. So in this case, this is a trapezium. So for us to find the value of t, we are going to use the formula for the area of a trapezium. Remember that when we are calculating distance, we use the formula for the area. So in this case, this is a trapezium and the total distance is given to be 550. So distance is equal to 1 over 2 a plus b times height. So d is the total distance. So the total distance is given to be 550. So let's now look at the value of A, the value of B, and height. So for the trapezium, so from 5 to 25, that is where the value of A is. So this is 5, this is 25. So to get the value of A, you need to subtract 25 minus 5. The answer is 20. So the value for A, it is 20. Then the value for B, it is from 0 to t. So this is where the value for B is. So this is the value for B. So B is equal to t. And this is the height. So the height is from 0 to 20, which is 20. So our height is 20, A is 20, and the value for B is t. So A, it is 20, B, it is t, height, it is 20. So from there, I'll say 2 into 2, 1. 2 into 20, we have 10. So I remain with 550 is equal to 20 plus t times 10. So to simplify, things here, I'll say over 10 over 10, so that 10 and 10 can go. I remain with 20 plus t is equal to 0 and 0 goes. I remain with 55. I'll collect the like terms. 20, it will go this side. So it will be t is equal to 55 minus 20. So the answer is 35 seconds. So this is the answer. Part C, calculate the average speed for the whole journey. So when you've been asked to calculate the average speed, this is the formula that we use. So average speed is equal to distance divided by time taken. Now we are looking for the whole journey. So we are going to get distance for the whole journey. It is 555. Distance for the whole journey, it is 550. And now the total time is 35. The total time is 35. So average speed is equal to distance is 550 over 35. So this is paper 1. You're not required to use a calculator, but you can do it better by saying 5 can go there. 5 into 35, it is 7. 5 into 55, it is 11. 5 into 0, it is 0. Now 7 can go into 110. So S is equal to 110 over 7. So there we can say 7 into 11, it is 1. Remainder 4. So I'll put a 4 there. It is going to be 40. 7 into 40, it is 5. And the remainder is 5 over 7 meter per second.